a bit, I'll cancel tonight. Okay, yang malam ni punya we cancel. Okay, and I want to propose the replacement class after Raya, which is gonna be still on what we call that, Thursday, tapi 18 April. Boleh tak everyone? 8 malam lah. We start at 8. Hello, can I get response?
15
Boleh doktor, boleh.
Apa dia? 18,
Boleh.
18, not 15. 18. Hari Khamis malam.
Okey doktor, boleh.
Boleh malam. We gonna do online. So if anyone has problem with the date, okay, please do let me know. Alright? Okay. Okay. Alright, please do let me know if anything, and then we can reschedule. So I'm sorry lah, I think let us cancel tonight class. Yelah, dah towards the end of Ramadan ni, takkan you guys nak miss out your tarawih kan? So I think macam it's not appropriate pula for us to, you know, chasing to do the to do replacement class. It's not like we cannot do the replacement class after Raya kan? Kenapa nak terkejar-kejar sangat nak do it, you know, within this time period and sacrifice the only time that we have for Ramadan kan, especially dah towards the end ni. So saya rasa macam sayang pula. Okay, so then I think let us focus on our ibadah insyaAllah. Then we're gonna resume our replacement class after the Raya. Okay, boleh everyone? Okay, yeah? Okay, kejap. Okay, let me share the screen. Okay. Alright, can you guys see my screen? You nampak semua? Okay. So since that last week we don't have class due to the public holiday Nuzul Quran. So then this week, which is today, we're gonna go through our first topic lah, topic 1. Okay, which is materials and basic principles of prestressing. Okay, prestressing application. Okay, boleh everyone? Yeah. Semua ada ke ni? Everyone, semua ada? Atia, Amar.
Ada doktor.
Okay, Syazwani.
Ada.
And Liana. Okay, make sure you guys don't forget to sign your attendance. Okay. Alright, so let's go through what you need to know from this course. First of all, you need to understand the principle and methods of pre-stressing. Second, able to differentiate between post-tension and pre-tension concrete method, because there are going to be 2 methods, so you have to understand both. Third, able to identify the difference between reinforced concrete and pre-stressed concrete. And fourth, able to give advantages of using pre-stressed concrete beam. And fifth, acquire the knowledge of materials used in prestressed concrete. Okay, so just a words, a wisdom today. So the first step in knowledge is to listen, then to be quiet and attentive, then to preserve it, okay, then to put it into practice, and then to spread it. So this is by Sufyan Ibn Uyainah. Okay, so you can, you know, take that notes. Okay, so first we start with what is prestressing. Okay, so what is prestressing? So when we are talking about what is prestressing, we go to the words of stress. Okay, we go to the word of stress. So when we go towards the words of stress, we know that stress is equal to P over A. Alright, so when you know the stress is equal to P over A, so you know that the P is the load, the A is the area. So means that the applied load to the area means you applied one load to the area. Okay, so that is what we call as a stress. So when we say pre, it means that it is pre-compressed, means it's pre-loaded. Okay, pre means that before it is being loaded. Okay, so in terms of pre-compressed means it's being preloaded. What does it mean? Okay, so it means that I always like to take this figure as a reference. Yeah, so we say that compression force produced by tension and tensioning of tendon to improve the performance of concrete. So this will suppress the tensile stresses. So basically, you say that you have a beam. Okay, you have a beam like this, and you have a truck on it. Okay, it's being loaded. The truck is on the beam. All right, so when the truck is on the beam, you can see that eventually there's a crack appear after some time, after over time. Okay, the crack will deflect. Obviously, the first when the truck is being placed on top of the beam, when you can see that the beam is started to deflect, and after over time, the deflection of the beam will cause crack. Okay, will cause this crack. Okay, so what will you do to improve the beam? Okay, so that it will not continuously what we call deflect. Okay, and and the crack will getting worse. So we will place a steel rod inside the beam. Okay, the steel rod inside the beam. Okay, so this is the steel rod. So once you put the steel rod inside the beam, so automatically you'll be able to avoid the beam from deflected. Okay, so when you pull the tendon or you pull the bar, okay, the rod, the steel rod, you pull it, okay, then it will make the beam getting much smaller, stronger. Okay, it's like you are pulling it to tension it. Okay, and when you, I'm looking for a paper. Just a paper, just so that I do the, okay. So have it. Okay, so when you remove the truck or the lorry, okay, what will you see is, for example, that you already pull the beam, you pull the tendon, okay, inside the beam. So the beam is actually under tension. So once you you remove the truck, so what you can see that the beam will hop, dia akan naik. Okay, dia akan naik. So this is what the concept of pre-stress we are talking about, because we want, when you pull the tendon, okay, inside the beam, you are what we call, you are strengthen the beam. So you are strengthen the beam in a way until when you remove the what we call the truck, so your beam will hop like this. So when you place the load on top of the beam, so the beam will flatten. Okay, the beam will flatten because you compress it, then it will be flattened. So the flatness of the beam, the cause of the thing that you put on top of the beam will not cause the beam to deflect anymore like before, because your beam already have a tendon that being pre-stressed, and the original state of the beam is hawk like this. Okay, after being pre-stressed, okay, the original state of the beam will hawk. So then when you place any load on top of it, it will be flattened. It will not deflect like the previous figure 1 that you see in the figure. Okay, boleh everyone? Do you get the principles of the pre-stress? Okay,
Clear,
Zahira?
Doktor.
Right. So benda ni is very important. So always picture always when you want to explain the principle of pre-stress, try to imagine this figure. Try to imagine the beam, and then you have the truck. Okay, what will happen to the conventional beam? So it will deflect and eventually it will crack, right? Then what you do to strengthen the beam? So you will put the rod inside. Okay, so when you put the rod inside, yeah, of course you're able to strengthen the beam so that the beam will not deflect. But if you pull it, then you apply force to your tendon, so means you kind of like pull the beam itself as well. So then you're providing extra strength so that it will pull up the your beam. Okay, when you release the load of your truck. Okay, so yeah, that's the principle. Hopefully everyone get that. Okay, so then we go to the advantages of pre-stress. Okay, the advantages of pre-stress. Why my kejap, I forgot to change to the hotspot. Why you listening? Not that. Yeah. Okay. Okay, all right. Okay, next we go to the advantages of pre-stress. Okay, so basically if you make a comparison between pre-stress and the conventional method, which is traditional method, okay, you can see there are several advantages. Okay, so basically for full pre-stress ni, when they will experience compression lah during their service life. So this is of course will cause some deficiency if you didn't apply a right procedure to it lah. I mean, okay, the first advantage is the obvious one. Okay, the section will remain uncracked under service load. Okay, that's the first one. So because of what? Because of they already strengthened the beam. Okay, so then it will not because when we design pre-stress, we will design so that the pre-stress beam will not deflect. So when the beam doesn't deflect, so then of course you will minimize the risk of the beam to crack. Okay, so that's one thing. So once you be able to minimize the risk of the beam to crack, so at the same time you could reduce the tendency of the steel corrosion of the bar. Okay, why? Because any crack in any beam, okay, it actually will create some gap. Alright, will create some gap, will create a hole. So this hole will be easily penetrated by water to seep through all through the cracks, any holes, and then they will get into the steel bar. So once they get into steel bar, then they will initiate corrosion. So things like that we need to avoid. Okay, and of course secondly, increase in durability. So whenever you able to reduce the corrosion, you're able to reduce the crack, of course the durability of the beam automatically will increase. Full section is utilized. Okay, full section is utilized. Means that if you if you design for a rectangular beam, you will get a full benefit of utilizing the the beam section. Okay, because for example, like you have this is a one beam, yeah, for example. This is a 300 times 400 mm. Okay, it's a common typical type of rectangular beam. Okay, so when you are using conventional, say that say that your W or your design load is around 50 kilonewton per meter. They are saying, yeah, and this is a conventional one. Say that you have a pre-stress one. So for pre-stress, you will have the same width 300, the same height, okay, which is 500, but the difference is it's a T section. Okay, it's a T section and it's much smaller or slimmer compared to the rectangular section, and it also be able to carry 50 kilonewton per meter, or sometimes will be more than 50 kilonewton per meter because of the existence of tendon here inside the TB. Okay, so in a way it says that able to fully utilize the section. All right, so without for example here, take the advantage of reducing the cost of the material, because if you compare this, even though it's the same size but different type of section, okay, but the amount of concrete used, of course rectangular will have more concrete than the T section. Okay, so in terms of cost of the material, using T section will be much cheaper than using the rectangular section. Okay, so that's what you mean by fully section is utilized. Okay, all right, then we have higher moment of inertia. So of course if you increase your durability, your reduce your section, of course you will get higher moment of inertia, less deformation. okay, reduce, your deformation of the beam is reduced, okay, because remains, you have the presence of your tendon. Increase in shear capacity, okay, in terms of the durability increase, of course, increase the shear capacity. Suitable for use in pressure vessels, liquid retaining structures and all. So improve performance, resilience under dynamic and also fatigue loading. Okay, so that's the first advantages. Second advantages I want to highlight here will be high span to depth ratio. So high span depth ratio is very critical for any structural element. Okay, especially if say that the structural element require a very long, require a longer span. Okay, a longer span such as we have for bridges, what I call fly over the highway. Okay, and it could also be if you have an opening in the building, you want your opening to not to have any column in between, all right, because probably it's a hall or it's a stadium wall and so on, so you need to be the span to as long as possible. All right, so for a conventional method to construct a long span without any column, you will end up with a design of rectangular beam which is it's going to be very huge. It could reach like 1 meter height. All right, because of your span, you want to design your beam to go with a span of maybe 20 meter, for example. That's long. A normal house, what we call a normal building, like a double-story house, for example, your beam from one column to one column is between 6 to 8 meter only. Okay, 6 to 8 meter. And you could design it as simply supported from one point to another point with 6 to 8 meter. But if you have longer than that, normally you will opt for continuous beam. So it means that you need to have column in between. All right. So even for 6-8 meter, if you don't want to have you want a clear span, that easily depends on the load, but that easily you will require to provide your beam like minimum maybe what we call minimum height will be 500 like that. So 500 is already about half a meter. Okay, so you can imagine how massive is the amount of concrete you have to provide or you have to use if say that your beam size is 1 meter, like 400 times 1 meter, for example. Okay, that's a lot. So then of course that will contribute to the higher cost. All right, so if your beam is already gigantically big, you just imagine what will be the size of your column, what will be the size of your foundation, because the beam weight will go to the will go to the column, all right, and the column will go to the foundation. So all that will take into matters, in terms of to provide the best what we call section size. Okay, and at the same time you have to think the cost of it as well, cost of the material especially. Okay, so for the same span, for example, you want to design for 20 meter. Okay, if say that for a conventional RC, you will require 1 meter depth, for example. But for if you are using pre-stress, you might not need 1 meter depth, 1 meter height. Okay, so for pre-stress, probably you just need maybe half of it, like 0.5 meter. Okay, height. So you already save the cost there in terms of the material use, in terms of the weight, because not only the beam weight, but of course in terms of other elements that attach to it, for example, slab, column, foundation and all. Okay, right? So for and then reduction in self-weight. So when you use lesser concrete, smaller section, of course you're gonna reduce the self-weight. More aesthetic appeal due to slender section. So I don't think anyone likes to see a very ugly big beam or column. Okay, because if you constructed 1 meter height of a beam, you can imagine how hideous it will be, because you cannot hide that that kind of beam. Okay, so it will be obviously can be seen. And once it can be seen like that, so of course the aesthetic value of the place lost. You wouldn't get it. Okay, so it's very important, very crucial for you to think of, especially if the design of the building requires some aesthetic values. Aesthetic values, normally you need the space to be as open as possible. Okay, and then you have all the decoration and so on, things like that. Okay, for the building. All right, and lastly will be a more economical section. Okay, so that will provide a good economical growth lah, right, to the country. Third will be suitable for precast concrete precast construction due to advantages of applying precast. Okay, so I always say that most all precast are pre-stressed, but not all pre-stressed are precast. Okay, because we can assume that precast is always going to be pre-stressed, but not all pre-stressed are precast. Okay. Alright, suitable for precast construction due to advantages of applying precast. Yes, definitely. So pre-stress, like we said, pre-stress and precast is always been together lah, yeah. Okay, so then we have the disadvantages of pre-stressed concrete. Okay, the disadvantages of pre-stressed concrete. So pre-stressing needs scale technology. So hence it is not as common as reinforced concrete design. Second, the use of high strength material is costly. Okay, so therefore, of course, one thing about pre-stress is you need to use what we call materials that is a high strength. You cannot simply use like concrete 20 or 35 like that. No, you cannot. Okay, why? Because when for pre-stressing, you need to apply tension to the tendon, right? So for you to be able to apply tension to the tendon, you need to apply certain value of forces to the tendon so that the tendon can produce you the stress. Okay, so then you need to pull lah, you need to pull. So that's why you need a skill technology and of course the workers. So in other words, it means that you need to pay more. Okay, you need to pay more. So then, of course, anything related to the cost will become the advantages. Huh? Okay. Second, the use of high strength material is costly. Yes, definitely. High strength material is very costly. Okay, no shortcut to it, but what we call, but you can. I mean, there's a way of it, so you can figure it out. Huh? Okay. And then you have the third one. There is an additional cost in auxiliary equipment. Okay, and the fifth one, we have there is need for quality control and also inspection. Okay. Alright, so this is the comparison between precast and pre-stress. Okay, I will say precast, so I will consider it as a pre-stress as well. Yeah? So don't get me wrong. So you can see in terms of comparison between both. Okay, I think this you can just read it lah. The advantages ni, it shouldn't be that complicated to understand. Okay, so now we go to the materials. Okay. Kejap before I proceed, kejap, give me some time jap. Okay. Kejap. Okay, alright. Everyone ada balik? Rizati okay?
Okay, Rata.
Okay. Ramai perempuan lah kelas ni. Ada 1, 2, 3, 4. Saya rasa dalam ada 5 kurang ke yang 5 lelaki. orang. Okay. Alright, let's continue. Okay, so we're talking about materials. There are 4 materials lah, yeah, that we commonly use. Okay, first will be means commonly used in the prestressed concrete. Yeah, we're talking about the prestressed concrete punya context. Okay, so first will be concrete. Okay, which is the common one lah, the main ingredient is just the concrete. Second, tendon and steel reinforcement. Third will be non-cementitious material. Fourth will be steel, structural steel bolts and also nuts. Okay. Alright, so talking about concrete, we're talking about concrete. Concrete requires higher concrete grade. So we talk about this, means that you want to use for pre-stress, you need to use concrete higher than 40 MPa. It cannot be lower. Alright. But then there are, depends on the class lah. There are some classes allowed, there's some not. But if you're following the guideline from PIC, it will be minimum 40 MPa. To accept stress and also distress, okay. To avoid large deformation will lead to losses. Okay, commercial anchorage for pre-stressing steel always designed on the basis of high strength concrete, which is weaker concrete either will require special anchorage or may fail under the application of pre-stress. So therefore it's very crucial to identify the strength first. For example, we have minimum concrete strength of concrete, so it's between 30 to 40 for each of the method. Alright, and we have minimum concrete strength at transfer, which is SCI 25 Newton per mm square, which is for pretension and also extension. Okay, but then of course this doesn't bound to this information because we still hold to the thought that pre-stressed concrete has to be minimum 40 MPa. Okay, so this is the strength. So I don't want to go further like this one. You can read it. So the strength of in the class stated. Okay, and then this is the tensile strength. So all this you can get the value from table 3.7, and this is the elastic modulus strength. Okay, the ECM values. Okay. Alright, so this is the table that you're going to use quite often this semester. So you will have the strength. For example, you take the strength is 40. So you go drag down. So what you can see here, 50 will be what we call FCKQ for the cube. So you have the top one for the cylinder, the bottom one is for the cube. Okay, and you have the FCTM, which is the load tensile of the concrete, and you have ECM, which is the modulus. Okay, the modulus. Alright. Okay, so in terms of this, you will see that the what we call the input the data. So because here is all being bought and then to give separately to others. Okay. Alright. That one is about table. So now we go for the tendon and steel reinforcement. Okay. Alright. So when you have pre-stressing, okay, okay, so pre-stressing, we apply both. We have Alright, sorry ada interruptions. Okay, so then we have pre-stressing steel. Okay, so for pre-stressing steel, okay, we are referring to the code, to the design code. Okay, we are still, so there's a specific clause that mentioning pre-stressing steel. Okay, and we can categorize the pre-stressing steel into 4 types. Okay, so first we have what we call as a wire. Right, so wire is made of a single made of the steel. So normally the diameter will be a bit smaller. Okay, so then we categorize it as a wire. Then we have what we call as a strand. Strand is consists of multiple number of wires in one strand. Okay, so then we have one strand. Then we have bars. Bars also can be used as a tendon or as a tendon where you use the bars, which is with the what you call the diameter, and then you pull it, and then it will act as a tendon. Okay, and we have what we call as a tendon itself. So by definition, it's actually one tendon is consists of a group of strand. So means that the multiple numbers of wire inside one strand, right? So we have that is called as one tendon. But somehow in pre-stress, when we have, especially we want to differentiate between bars. We want to differentiate between reinforcement bars that is not tension and with the bar reinforcement bar that is not tension. Okay, so reinforcement bar that we use as to pre-stress or to you pull the bars is normally we call as a tendon. Okay, we call it as a tendon because in one beam of pre-stress beam we might have a reinforcement bar that is not being pulled. So that reinforcement bar will act as a reinforcement bar. It's not going to act as a tendon. Okay, so to avoid the confusion, normally we do always refer to, if say that the beam is using bar as a tendon, so we call it as a tendon as well, just to avoid, because normally sometimes in one beam we could have both, the bars, the tendon, and also the originally reinforcement bar. Okay, so this is a figure or a table whereby you can see that the type of available type of tendon. Yeah, so here itself, you look here, the combination of pre-stressing tendon, even the wire also they call it as a tendon, by definition, not by exact definition. Okay, so this table is actually, I just took it randomly from the internet. So this kind of table is what the information that you always commonly will get from your manufacturer. Okay, you will get that kind of information. Okay, this kind of information is whereby it depends on which manufacturer that you are dealing with for you to for them to provide you the reinforcement. Okay, for you to for your pre-stress beam. Okay, because you need to design, so you need to make sure that you are using the characteristic of the material that you want to design. Okay, according to which manufacturer that you're going to buy the tendon from. Okay, so basically if you look here, if you look into the details, so you have size and then the diameter, and also in terms of shape, so you have so many type of shape. All right, even the wire itself, so normally you can look into the wire diameter is normally is going to be like 2 mm to 9 mm, commonly will be 7 mm, or you could also up to 13 mm, so it really depends. So this one like 2, okay, here will be 7 wire strands. So 7 wire means that in the diameter itself, this diameter is equivalent to 6.2 to 15.2. right? So all that give you the details of what type of materials that you're gonna use for your tendon. And you could also find this kind of table which give you the materials, the diameter, the tensile strength. So this value of tensile strength and yield strength is the two materials values that are very crucial for you to be able to design. Okay. Alright, and this is also another examples of the type of tendon that available. So then you can refer to it. Okay, boleh everyone? Is there any question, Rosnani? Okay, who else? Hi Sarah, soalan?
Tak ada, doktor.
Okay, Atiyah okay?
Okay, doktor.
Umar?
No question, doctor.
Alright. Okay, so hopefully everyone is clear, yeah? Okay, now we go by application. So prestressed concrete, where is being used? So prestressed concrete commonly being used in buildings. Okay, we do have prestressed used in underground structures such as tunnel. We have towers, water storage, offshore structures, numerous type of bridge system including cable stayed and also segmental bridges. We have also nuclear reactor vessels also use pre-stress, yeah. Okay, for example, in a way we can say that it doesn't matter what type of the structure, it just matter either it can utilize the technology of pre-stress or not. Okay, if you look here, the picture that I showed here, this is kind of like one piece, yeah, one piece of wall. Okay, one piece of wall with a hole. This is what we call as a precast. So we say that precast, when we say precast, we say that all precast are pre-stressed. So in a way, it's a pre-stressed element as well. Okay, and you can see the crane up, trying to lift one element to another element to place it at the exact location that they need. Okay, and this is example of the what we call structural bolt and nut. Okay. Oh, I forgot to mention about something, yeah. The two other materials. Kejap. Talking about bolts and nuts, kan? Okay. So as we go for the 4 ni, you know that these two concrete and steel is a compulsory. So non-cementitious material could be like grout. It could be any cement render materials that used to rendering surface and so on. So grout, to fill up the gap for any gap. So that will be used. Then we call it as a non-cementitious material. And then the last material that we use is structural steel. Like bolts, nut, like what you see in the figure here. Okay. So you can see the system of the bolt and nut. Okay, bolt and nut there. All right. So here you can see how all right. So you can see that how they lift this piece, to the construction by using the crane. All right. All right. So then you have bridges. Okay, and you have segmented bridges. So bridges normally come with segment element like this. You see that this segment is actually hollow. It's a hollow part. So you just imagine if this is a conventional method, yeah. So then you have to use a solid what we call segment. So by using solid segment, you will, of course, the weight will be increased. And then of course the beam weight increase, then of course your pier here will also increase, your foundation also will increase. Okay, so it's going to be very huge structure. All right, so this is an example of a detail of a segmented bridge element. So you have the diaphragm to hold the tendon for the external tendon. You have the internal tendon, so you have corrugated steel web. So you have the top flange and all. So it gives you, the idea of precast for segmental is mostly are all pre-stressed. Okay. Alright, then we have water or oil storage. Okay, and this is an example of the Mizusawa egg-shaped digester. This is a tower, so you can imagine that. Okay, where is the picture? Okay. Alright, so this is a tower. You can imagine that it's not being like cast in the whole length to cast in the manufacturer at the factory and all, but they cast it piece by piece, and then they will bring it to the site, and they're gonna cast out, connect one element to another element and make it as a tower. Okay. Alright, and we could also have the tunnel. So if you look here, the tunnel, it comes with the 3 pieces. Okay, like this. So it's a 3 pieces parts. Okay, and the parts ni you can see from here. This is example of the parts. Dia datang macam tu. Okay, so then you can assemble it on at the site. Okay, and that will become much faster. Okay, and of course, but of course in terms of the other thing, you have to be ni lah. Okay. Alright. Okay. Alright, sorry, ada distraction tadi. Okay. Alright, so let's continue. Okay, why not we take 5 kejap before I proceed with these methods. Okay, we take 5 boleh? Not 5 lah. We maybe 10 lah kot. You guys boleh go toilet ke fresh up petang-petang ni kan. Alright, maybe we continue back around 3 boleh everyone? Lagi
Okay,
10 minutes.
boleh doktor. Boleh.
Okay, go. Okay, let's continue. Boleh, everyone? Dah ada ke semua? Fadli?
Doktor.
Boleh doktor.
Okay. Azwani, okay.
Masih okey, Doktor.
Bridget, masih okay. Bridget, okay?
Okey, doktor.
Alright. Siapa lagi ada? Faiz. Okay, Faiz. Okay, Faiz. Faiz.
Ya doktor.
Ha, tidur tadi.
Sorry.
Okay, alright. So we continue with the methods. Okay, for us to achieve the pre-stressing, the pre-stressing beam, ataupun the what we call pre-compression beam. Okay, for us to achieve the condition of it, okay, there are two methods. Right, first method will be called pre-tensioning. Okay, second method will be called post-tensioning. Okay, so pre-tensioning is whereby we have what we call, okay, let us go to the words. The two methods, the difference between these two methods is the word pre and post. Alright, so the main question here, it should be pre means before, post means after. So it is before what and after what. Okay, alright, so hold to that thought. So here is this method is used to manufacture for pre-tensioning. Manufacture a large number of similar precast pre-stressed concrete products such as simply supported beam, one-way spanning slab, and railway sleepers. So this is a common factory-based operation. So once it says it's a factory-based operation, automatically we know that it is precast element. So that's why we say most of precast are pre-stressed. Okay, so the pre-tensioning is a method that commonly we use, it is factory-based operation. Okay, and we have another method we call as a post-tensioning. So post-tensioning means after. Alright, so after what? Later we'll see after what. So this method is commonly used on-site operation, like in situ construction site. So it's generally used to pre-stress simply supported continuous beam, two-way spanning slab, statically indeterminate structures such as frames and also bridge structures. Okay, so pre-tensioning commonly is in the factory, is a factory-based operation, and post-tensioning is a on-site operation. Okay, so please take note that. Okay, so we go one by one. So before this we take into account the word pre. So pre means before what? So before casting of the concrete. Okay, the word is before casting of the concrete. Alright, so how is it happen? So basically, if you look into the figure here, you have a pre-stressing bed. This is pre-stressing bed. Pre-stressing bed is like a big mold, big mold. Alright, so what you do, the first thing, because it's a pre-tensioning method, the first thing that you do is you're gonna apply or you're gonna place in your tendon. So once you place in your tendon, the first thing you do is you're gonna pull the tendon. Alright, once your tendon has been pulled to certain capacity, okay, the capacity is what you have to design. We have to design the capacity, how much you want to pull the tendon. So say that it's already pulled according to the capacity. Then what you do is you're gonna concrete. You're gonna put in the concrete. Okay, you're gonna put in the concrete. So if the tendon is already there, so it means that you're gonna embed the tendon inside the concrete. Okay, so then you're gonna wait the concrete to harden. So once the concrete is hardened, then you can just simply cut the tendon out to release it from the pre-stressing bed. Okay, so therefore that's why we see, remember the truck and also the simply supported. So then your beam will kind of like concave a bit like this. They akan like hog naik. Yeah. So whenever you bring it to the side of the this pre-stressed beam, so when you apply the load, so you can avoid the beam from deflecting. Okay. Boleh everyone? Are we clear?
Ya, doktor.
Right. So that will be the first method. Okay. Mazatul okay?
Okay, doctor.
Alright, so next, so you can see the stages, right? So you have the anchoring of tendon against the end abutments. Okay, that one is the anchor lah, means that you want to place the tendon. Okay, then you place the jack. So the jack is the round circle where you gotta pull the tendon. So then you apply tension to the tendon, means you pull the tendon. So after your tendon is being pulled, then you can cast the concrete, means you put in the concrete inside the bed. Then when it's hardened, then you can cut the tendon out. Okay, alright, so this is the what we call the hardwares lah, yeah, of the pre-tensioning. So you have all these what we call the strands, the anchor, you know, to hold down and so on. Okay, let's watch this video, shall we? This video doesn't have sound. Okay, you can see the bars. Okay, this is not a reinforcement bar. This is a heating bar. Okay, heating bar normally in the factory. Okay, we use the heating bar so that we can heat the concrete, so we can accelerate the time for the concrete to harden. Okay, alright. Okay, so then you will place the both molds, both sides. Okay. Right. Then you're gonna place the placement of your tendon. Okay. Interlock it. Okay, then you slot in your wires. It looks small here, so probably it's a wire lah. Right. Then you're gonna pull the wire. Okay. Then you will start to put in concrete inside. Okay, and flatten it, the surface. Okay, and you will cover it so that you can heat the specimen so that your concrete will harden. You can see that it started to heat. Ooh. Okay, alright, boleh everyone? Are you clear? Boleh? Zarifah? Zarifah, Zahida?
Yes, doctor.
Boleh?
Boleh, doctor.
Okay, alright. So that is one method, yeah. We call it as a pre-tensioning. So remember the word pre, so means that when we say that pre-tensioning, so means that the tendon is being pulled before. Pre means before the concrete. Okay, before the concreting. Okay, so the next method we have is post-tensioning. So post means after. So after what? After the concreting. Okay, means that you pull the tendon after the concreting. Okay, so for post-tensioning, since that we're going to cast the concrete first. Alright, so we're going to cast the concrete first. So when we cast the concrete, you have to make sure that if you recall back the pre-tension just now, okay, the procedure. Okay, you pull the tendon. Okay, you pull the tendon, then you put in the concrete. So basically your tendon is already in the concrete, then the concrete hardened. So the tendon is kind of like attached to the concrete. But now you want to do the concreting first. So if say that you didn't allow some space for the tendon, so there will be impossible for you to place the tendon, because if you place the tendon earlier, then you do the concrete, you cannot pull the tendon because the tendon is already stuck, or is already embedded in the concrete. Okay, so you cannot pull the tendon. So how to make sure that you can allow a space for you to have the tendon inside the concrete and for you to be able to pull the tendon. So therefore we provide what we call as a duct. Okay, so this is duct. Okay, the white one you see here is what we call as a duct. Ducting. Okay, ducting is like a big pipe. Okay, it creates empty spaces inside your pre-stressed beam, and with that empty spaces you can slot in your tendon. Okay, you can slot in your tendon and you can pull it. Okay, so the tension is applied to the tendon located in the duct, after hardening of the concrete. So normally you will wait it until hardened. It depends. Sometimes you can put it earlier, the tendon inside the ducting, or after the concrete is hardened. So once it's in there, then when after the concrete is hardened, then you pull the tendon. So once you pull the tendon after certain forces, then you will lock it by putting the anchor at both sides so that it will not move, because you're going to release. So if you release without locking, so then, well, your what we call then the pulling is useless lah. I mean, there's no point, because you don't able to capture the load, okay, the strength. All right. So the pre-compression is transmitted from steel to concrete by the anchorage device at the end of the block. Okay, so if you look into the stage of post-tensioning, first you cast the concrete, second you place the tendon, okay, third will be the placement of the anchorage block and jack, okay, which is the jack is a hydraulic jack lah in a way. Apply tension to the tendon, then you pull the tendon, then you sitting of the wedges, means you want to lock the tendon from any movement, okay, and lastly you'll be able to cut the tendon once it is settled. Okay, so the process of this, you can see the procedure. So see the guy here is holding the anchor, right, of the tendons. Okay, so this is actually the slot in the anchor and also the wedges of the tendon. So then they're going to position the hydraulic jack. So this is the hydraulic jack. Okay, the hydraulic jack here will able to pull the tendon by providing a certain pre-stress force. Okay. Then you have what we call seat stressing, so you keep on pressing, and of course lastly they will what we call sitting the wedges to lock it from any movement, okay, from releasing. And when talking about what we call hardware for the post tensioning, it's a bit critical compared to pre-tensioning, because of it is not embed directly with the concrete. So after you pull the tendon, the movement is still there. You can see, because there's a gap between the tendon and also the ducting area. Okay, so because ducting is like a hollow, and you have to make sure that your what we call your tendon is much smaller lah than your ducting diameter, because if it's bigger or it's the same, so then you cannot slot in your tendon. Okay, so in terms of that, so you have your ducting. So your ducting, this is considered as your ducting. This is what we call as a flat duct. Okay, it's not a round duct. So ducting itself will have so many types. For example, this one is the type of round ducting, the circular one. Okay, like a pipe. So this one is flat ducting. So with this is all the anchorage systems lah. Okay, the anchorage system that holding the ducting, okay, while you are pulling it using your hydraulic jack. Okay, and you can see also this one. In each of the anchor, normally you will see this. So this is what we call as a grout tube. Okay, so what is grout? So grout is actually a composition of you normally will have cement. It's a special type of cement because it can reach a certain strength. Okay, water, sand, a bit sand, and also water. So this is normally it's a ready mixture. It's some type of sand put, it's like just a cement, but it's a type of cement that can, you can have can reach out certain strength lah from the grout. So normally you're gonna mix the grout with water, then you're gonna have like a liquid paste like that, right? So then you're gonna pump into this tube. This is what we call as a grout tube. Okay, you're gonna pump in. So what is the point of why you need to pump in? Because there are two conditions. There are two options for post tensioning. Either you want to pump in your grout to fill in the gap between the tendon and also the ducting area. You want to fill in so that there's your tendon cannot move, or you can just leave it. Okay, means you just leave it, means you didn't grout. So means there always going to be a gap between the tendon and also the what we call the ducting surface. Okay. Alright, so this is the duct. Okay, you can see like a drum, like a a long piping, but normally it's made of aluminium. It makes of HDPE, plastic, and sort of that kind of material. Okay, so now let's go to the bonded tendon and also unbonded tendon. So bonded tendon is the option that we mentioned just now, whereby the condition of the post tensioning, either you want to put grout or you don't. So if you pump in grout, okay, so basically you will see that the grout post tension, grouted post tension tendons are what we call as a bonded tendon. So means that your tendon is bonded, all right, directly to your prestressed beam because there's no gap. So means that it is bonded. Okay, so the advantage of it is actually large reduction in additional reinforcement requirement as tendon cannot distress in accident because they cannot move. It's already embedded in the concrete. Alright, so the purpose of bonded ni is actually they were going to provide protection for the tendon from any kind of correction. Okay, so now we go for unbonded tendon. So unbonded tendon is where there's no bond. Okay, it means that you didn't pump in grout. So when you didn't pump in grout, there will always going to be a gap between the tendon and also the ducting surface. Okay, there will be a gap. But then of course, when you have a gap, so there will be a tendency or possibility of the water seeping through the holes or any pores or any small crack. They're gonna pass, they're gonna get through, and then they're gonna be able to cause the reinforcement or tendon to corrosion. So therefore, that's why when you want to opt for unbonded tendon, okay, so normally we will coat the tendon with grease to avoid it from corrosion. Okay, so what will be the disadvantages? So the advantages is the cable can distress itself. Maknanya they can shrink, they can extend. Still, still is like a behavior of steel is always like it's not gonna be rigid, kan? Okay, and burst out of the slab if damaged because there's a gap. So when there's a gap, so the movement is allowed for the tendon. So it might be at one point when the load is too much, then it distress itself, and of course it can burst out. Okay. All right. Let's watch this for the post tensioning. This is
Step 1. Bomber set up. Step 2. Placing of bottom reinforcement. Step 3. Fixing of bar chair for post tension tendon. Step 4. Placing post tension tendon. Step 5. Fixing anchorage bustering reinforcement. Step 6. Placing of top reinforcement. Step 7. Placing anchorage pocket former and grout vent.
Okay, sebelum tu saya nak tunjukkan.
Step 6.
Okay, so this one is the ducting, the flat ducting tu. Okay, they place the flat ducting. Alright, flat ducting, flat ducting. Okay, cakap.
Placing.
Alright.
Step 8. Fixing slab edge former with pocket former. Step 9. Concreting of slab. Step 10. Remove slab edge former. Step 11. Remove pocket former. Step 12. Placing anchor head and wedge in position. Step 13. Stressing. Step 14. Cutting end of strand. Step 15. Capping stressing reset with cement mortar. Step 16. Grouting. Step 17. Repeat for next 4 slabs.
Okay, kejap. Kejap, I ada some Confusion. Wait. Kejap. Kejap, give me a minute ya. Okay, boleh? The video just now? Nampak clear?
Clear, Doctor.
Alright. So this kind of video, please take your own alternative. Take your own effort to go through, and you will find so much input in the YouTube, especially in the construction wise. So please do take some time while you're waiting for your buka ke, instead of just watching Korean ke whatever things that you guys are watching nowadays. So at least take your time to watch, what I call this kind of videos. It helps, and it will make you much more, interested to learn, this course. Okay. And furthermore, it is important for you to be able to visualize the process, or visualize the construction work, visualize in terms of the how it's being constructed, how it is being installed on site. Because what you call, in terms of technology, they go very fast, very fast. And then sometimes for you to cope with the technology, you cannot just simply explain it during the lecture hours. Okay, so therefore, for you to grab that kind of knowledge, you can, simply spend like 5 minutes, sometimes not even 5 minutes, but 2-3 minutes for one video. At least that helps you to understand this course better. Okay, alright. Alamak, saya punya slide dah hang, cannot move. Okay, so I have another one. Okay, you can watch it.
Step 1. Install soffit formwork. Step 2. Install side formwork. Step 3. Install reinforcement. Step 4. Install bar share for tendon profile. 5. Install. Step 6. Push strand into duct and install anchor plate with spiral reinforcement. Step 7. Complete install of every tendon. Step 8. Complete side formwork. Step 9. Complete end of formwork. Step 10. Concreting. Step 11. Install anchor head and weight. Step 12. Dressing. Step 13. Cutting end of strand. Step 14. Install anchor grout cap. Step 15. Grouting. Step 16. Remove grout cap.
Okay, boleh? Alright, I just want to highlight here, in here, I just noticed something interesting. Okay. Okay, did you see this one? This part? You nampak ada like a spiral. Do you see? Nampak tak? Alamak. Nampak ada spiral. Okay. That spiral tu is actually meant for end block design. Okay, later we will learn as well end block design, whereby we provide the reinforcement, the spiral reinforcement to ensure that when you pull the tendon, it will not affect the concrete, because the distance between that distance to the hydraulic jack where you want to pull the tendon to is a bit closer and close, kan? So then of course the concentration of the force too will be very concentrated at that length. So therefore they provide extra we provide extra reinforcement just to avoid you know, the concrete from bursting, from fail, right, from rupture lah, from failure. Okay, right. So yeah, later I will give you there is a exercise for you today that I will give. So I expect you to find one good video. Okay, one of the question is asking you to find a video. All right, so please spend your time to find a good video, right, for you to watch and to really what you call, understand the this course, yeah, especially pre-stress lah, the method, the technique and so on. Okay. All right, so let's proceed. Alamak, dia dah hang. Okay. All right, now we go with design consideration. Okay, so design consideration is whereby you know, what are the philosophy or design that we use to design prestressed concrete. Okay, so in terms of when we want to consider the design consideration, we can make these two comparison. Okay, one, if you recall back what you have done in your RC, yeah? So in your RC design, so you design based on ultimate limit state. So what do you do? So when you design based on ultimate limit state, so you will calculate your W, right, your design load, okay, and your W will be factored. Okay, for example, 1.35 JK plus with 1.5 QK, right? So it will be a factored load. Means that you allow some factor of safety. Okay, so instead of, for example, your W probably GK plus QK is only like maybe 60 kilonewton per meter, but when you factor it, now it become like almost 130 kilonewton per meter. So you design based on this. So basically when you design with 130, then it shows that, you know, then your size is actually over design lah, because what you need is only for 60 for actual load. But then since that you want to make sure that, you know, there are always an issue in terms of design, kan, poor workmanship ke, poor materials ke, so you are allowing your design to be over designed, so that if it fail, it will not fail immediately, because you already extend the design load. Okay, so when you calculate your W, so next is normally you will calculate your M. Okay, and then you will compare with your M resistance, and you will calculate your AS required. So your AS required is calculated based on your moment design, your MED design, correct or not? Alright, so you get your AS required, which is your area, diameter of your bar, okay, your number of the bar, all based on your AS required. So what does it mean? It means that you want to make sure that when you design, you don't want your beam to design against your moment. Okay, your MED has to be, you know, bigger than your resistance. All right, lesser than your resistance. Okay, so your what we call your beam, okay, when you design, it will not fail against moment when you provide a sufficient number or a sufficient size of your reinforcement bar. So your beam will not fail. Okay, so that makes then that is what we call as the ultimate limit state, because then you also based on your shear. Okay, you calculate your V, RC semua and VET semua and everything, and then you provide what is will be the sufficient link to be provided for your beam so that your beam will not fail against shear. So there are two main things here. One will be your moment and one will be your shear. And of course the other things you have torsional and so on too will be extra stuff, but the main two things is moment and shear. Okay, so this is the ultimate failure that the beam will experience in a concept of beam, right? But then different with prestressed concrete design. Okay, we don't design our beam for prestressed concrete based on moment and based on our shear. Okay, so what we base on what we call as severity limit state, whereby we take into the consideration of bending stress, or in a way we also say deflection lah. We don't want the beam to deflect. Remember the picture of the truck on the beam? Okay, so we don't want the beam to deflect, because if the beam deflect, that will create crack. So we don't want the beam to deflect. So our basis in our design is not to let the beam to deflect. Okay, so therefore when the same goes when you calculate your deflection in your ultimate limit state. Okay, you calculate your deflection in your ultimate limit state, you don't factor your load. Means you will take the actual loads values without factor the loads. Okay, so the same goes when you design for pre-stress. You don't use 1.35 GK plus 1.5 QK. You will take the load as GK and also QK, because what you want to know is what the beam is actual experience, at service, which is what they will experience is the actual load. Alright, so the actual load maknanya more critical lah bila kita design tu, because we will design it critically. Okay, so what we call so then from there you will from the values, okay, severity limit state, which is the unfactored load. So then you will design what will be the bending stress. Okay, you will design the stress, the total stress experienced the beam will be all based on the bending stress. Okay, or stress that caused directly to the beam. Okay, it's not only moment stress or moment values. Okay, so because the aim is to provide a sufficient size of a pre-stressed beam, a sufficient number of the diameter of your tendon, the diameter of the tendon, the number of the tendon, the position of the tendon, to make sure that your beam will not deflect. Okay, alright, faham? Do you get it? The difference between RC design and also prestressed concrete design. Zarish, okay? Faham? Do you get that?
Okay.
Zulaika, boleh faham?
Yes, Doctor.
Fadli? Mana Fadli?
Fadli, Doktor.
Fadli.
Okey, Doktor.
Okay, boleh, faham.
Doktor.
Alright, Anwar, okay Anwar?
Okay, Doktor. No problem.
Okay, so hopefully you are clear about the principle, the difference, because I don't want you guys when we proceed with the design nanti ada confused lagi. Ataupun dalam when you answer your exam ke apa kan, kenapa this one is not factored? Why this one doesn't multiply with 1.35? Why this one doesn't calculate the moment resistance, for example? No. Okay, alright. Okay, so the design consideration, if you're talking about class 1, class 2, class 3, it's actually more or less the same principle lah as what we have in our RC. Okay, and this class is actually represented by class 1, class 2, class 3, and we can say that class 1 and class 2 is meant for the severity limit state, where we design for SLS. And then kita design with the consideration of unfactored loads, and then the deflection values and bending stresses. But then once we already design our beam, once we design our prestressed beam, and when we design it means we already provide the number of the tendon. You already know what the diameter of the tendon we want to use, the position of the tendon we want to use, the force that we want to apply for tension. Okay, all that parameter we already know. So then we have to check for ULS. Okay, we have to check for ULS. Alright, we have to check for ULS. What do you mean by check for ULS? Means with all the parameter already set, you're going to use the parameter to check for ULS. Means you're going to use the equation for calculating the moment resistance, moment design and so on. Okay, and you will be able to calculate is it okay or not, the total moment to sufficient or not, is it the tendon can tackle can carry or not the moment. Because if the applied moment, so if the tendon cannot carry the maybe the not all moment that they can carry, there are some of the moments cannot carry, the tendon cannot absorb the moment. So then you have to provide additional reinforcement. Maknanya you kena provide reinforcement bar lah. But this reinforcement bar will not be pulled. It's not a tendon. It's just a reinforcement bar. Okay, so this is normally we experience for class 1 and class 2, whereby your tension will be equal to 0. Okay, alright, and this one it will be very small lah. Your tension is very small. Okay, and if you look back into the ultimate limit state, so this is actually represented by class 3. So it means you design for ULS and you check for SLS, because this is what you did in your RC. You design for ULS, means you design based on your moment, your shear, and then you check for your SLS, means that you check for your deflection, your crack, smooth. All that is actually the severity limit state criteria, okay, element. Okay, and this is just to show you the stress limits, okay, of the tensile stresses. Okay, FCT is 0.6, the FCS which is 0.6, FCK as well, which is 60%. You can read through. Okay, and of course you have for FCS for quasi-permanent loads as well. So this one later we will go through in depth lah, okay, in different topic inshallah. Alright, and of course the stress limit of the WMX recommended values lah. Okay. Alright, so okay, that's all. Is there any questions, soalan?
So far tak ada lagi doktor.
Okay, alright. Siapa lagi? Okay. Arif? Mana Arif Farhan?
Ya doktor.
Okay, boleh follow? Can you follow?
Boleh.
Right. Okay, so I will stop here. Okay, I'm not planning to continue new topics because if I continue then I don't think I can finish on time. Okay. And then furthermore you're gonna it's gonna be a long break for your eat. So I think better we start next after Raya lah for the topic. Okay, and what we call but then I will release you the exercise after this. So I expect you guys to use the time, okay, because actually our time is supposed to be until 5 o'clock, right? Today, correct?
Yes.
Yes, doctor.
Okay, so please use the time, the 1 hour time, okay, for you to do the exercise that I will give. It's like a self studying lah, yeah, because that is for your class because it's a 3 hours class. So normally that's what I do lah. Kalau I buat lecture pun, I will be 2 hours lectures. Okay, and 1 lecture to more to discussions ke, or more to do exercise and so on. So if say that if you have problems, then you can just simply ask me directly lah during the 1 hour. It's just matter of you have to do it on your own lah. You try yourself first. But for this topic, it's not much exercise. I mean, it's not calculation exercise. Okay, so please take your time. Use the time. Okay, until 5 o'clock. Okay, for you to find to complete the exercise. Okay, it's non-graded. The exercise, like I said, is non-graded. Saya takkan check pun your work tu, but because you are actually doing it for yourself, not for me pun. Okay. Alright, so yeah, I think, is there any question before I end the session to distribute your assignment? Not assignment, your exercise. Ada soalan?
No.
Ada soalan?
Tak ada.
Ada.
No, madam.
Okay, good. Alright. Ruhaiza ni Ruhaiza.
Yeah.
Okay. Semua dah tukar gambar?
Ya.
Okay, good. Ada juga yang saya tak dapat nampak. I don't know why. Saya kena klik nama satu-satu baru saya nampak. Zahida mana Zahida? Dah tukar gambar belum?
Dah, Doktor.
Saya klik tak nampak. Oh, maybe you kena log out nanti kot. Balkis pun saya tak nampak. You dah tukar ke? Balkis.
Belum ada sebab hari tu dia problem. Nanti saya try balik.
Okay. Jangan try sampai next sem sudah. Farhan Najiha. Try your best ya. Najiha.
Ya.
Dah tukar gambar belum?
Ada.
Dah, bila? Tadi?
Dah lama dah. Semalam, 2 hari lepas kot.
Yeah, tapi tak nampak. Dia tak keluar. Okay, never mind. I don't know. Sometimes Microsoft Teams memang ada problem tu. But then those yang dah tukar, please, yang tak tukar, please tukar lah ya. Alright, simple instruction takkan you tak boleh nak follow kan. It's just a simple thing. Because from time to time, sometimes we do gonna have what we call online classes kan. All that it will be easier. Alright. Okay. Okay, so I think that's all from me. So I'll be seeing you inshallah after the break of Eid. Okay. Then I think Selamat Hari Raya to all of you. Maaf Zahir dan Batin. Okay, may you guys have a great celebration with your dear families and also friends. Okay, inshallah we'll be seeing you back physically in the class next week. Alright? Next week lah. After Raya. Okay, so it's gonna be like another week lah kan, something like that, because we gonna have 1 week break. Okay, so till then, take care everyone. Thank you very much. Assalamualaikum warahmatullahi.
Waalaikumsalam.
Thank you, Doktor.
Thank you, Doktor.
Thank you, Doktor.
Thank you.